Hello everyone. Today we are going to do the experiment single slit and double slit PH5P1. The aim of this experiment is to observe the diffraction patterns due to single and double slit and to calculate the slit widths accordingly. The principle of this is basically very simple. We will first proceed with first doing a single slit, and then we will do with this double slit, and just using the equilateral triangle equivalence and the formulas that we have present here, we will find out with the distance of the slit from the laser from the screen. We will find out the diffraction patterns, measure the distances between each pattern and slit, and then proceed with the next of the experiment. So here in this side we have a laser. The nanometer of the laser is given is 625 nanometers, the wavelength of the laser, and then we have the laser and the slit that we are using. So currently we are using the single slit. The single slit, basically the pattern which you can observe there, you will always find a minima in the center, and then all the other patterns that you will get in the side, the maximas will slowly start to fade away. So basically it's just one central maxima and all other central maximas from the other side. So in here the first minima that you find is the zeroth minima. The first minima is the zeroth minima, and the next minima from that, that's the dark fringe, is the first minima. So in the table that's given here, we have to first find the distance between the screen in the magnitude of millimeters, then from the central maxima to the mth order minima. So we usually just take the first orders. The first three will be the first order, the second three will be the second order. So we will find the distance between each, left, right and mean, and while using the formulas we can find out the angles, and then we can put it into these formulas to find the slit width of the single slit. Okay, so here we can see that this is the maxima that we get from the single slit. The first dark fringe that you get is the zeroth minima, and this is the first minima. So if you are going to measure by taking m equal to 1, we have to take the distance from the central of the maxima to the first minima, that is actually the second dark fringe. So, and the third dark fringe that you get is actually the second order minima, that is when you need to take m is equal to 2. The capital D in the tabular column, it is actually a distance between the screen and the slit. So you measure it from this side of the wherever the slit is to the screen. So this is basically capital D. We do not consider the distance of the laser from the slit. We just consider distance of the slit to the screen. Okay. So now we are going to proceed with the same apparatus. We just change the single slit to a double slit. So in double slit, is basically the tabular column is exactly the same. In here though, we take the distance between a central maxima to a maxima, that is the mth order maxima, whichever we're going to measure. So basically we do it for the first order and the next three for the second order. So in double slit you can observe that the pattern is a bit different. The difference is because there are two sources of light that passes through at this point, because there are two coherent sources of light. You can see that the maxima that we're getting in the middle are actually a pattern of different maximas of the same constant monochromatic light. So because of this we get slit of maximus, one next to the other. So here you can observe that the central maxima is the one that is in the middle, exact middle. So this one is the central maxima. So this central maxima, we have to measure the second maxima from it. So the second maxima, just exactly as the single slit that we did, like the second minima was the first order, the second maxima will also be the first order in this case. So just like this, we'll proceed with the experiment. We'll measure the distance between this with the help of a scale. We'll take capital D, and then with the help of these values we'll find the angle of diffraction, and from here we can proceed to find the slit of the double slit as well.